fractions. All right, 9/16, 3/4. Now, to compare and order fractions, we always have to use the least common denominator. Okay, we need the LCD, which is the same thing as the LCM. Okay, it's just in the form of a denominator now instead of not just two numbers. Okay, so what we need to do is we need to find the LCD of 4 and 16. Okay, the reason we're doing 4 and 16 because those are our denominators. Okay, because what we need to do is we need to make an equivalent fraction. Okay, we need to make an equivalent fraction. For them to be equivalent, they obviously have to have the same denominator. So, our LCD of 4 and 16 is equal to what? 4. No. Remember, least common multiple. Okay, stop. So, I want you to count by 4 and tell me when you get to 2. Yeah, oh. It's what? It's 16. Okay, it's 16. The reason it is 16 is because if you count by 4s and you count by 16, that's the first thing you run into. Okay? Remember, least common multiple. Multiples are not factors. Don't get the two confused. Okay? So, I'm going to make two equivalent fractions with 16 on the bottom. Okay, now, obviously our first fraction is already 16, so I just need to bring the 9 down. The second fraction is 3/4, so I have to multiply 4 by 4 to get 16. Same thing on top. Okay, so therefore, 3/4 would be the bigger fraction because 12 is larger than 9. Okay, so let's look at another one. Five, 6, and 7/8. 5, 6, and 7/8. So the first thing is we have to find the LCD, least common denominator, of 6 and 8. 24. Okay? So the fraction, our least common denominator of 6 and 8 is equal to 24. Okay, now, if you don't know how you get that, if you can't just see it, okay, there's two ways to basically do it. With a lot of these fractions, you can do it by counting by the numbers like we did on the first one. 6, 12, 18, 24, 30. You count by 8, 16, 24, 32. Okay? With some of the larger denominators, when we get into the larger denominators, you're going to have to be able to do the LCM that we did, last night. So, we'll get to that here in a second when we get to some different denominators. It's a little harder. So our denominator is 24 for both fractions. Okay, so we multiplied by 4 to get 24, so we got to do the same thing to the top, which is 20. Multiplied by 3, so we got to do the same thing to the top, that's 21. So the 7/8 is larger. So we put the less than sign in the blank. Okay, now, how I'm coming up with these numbers is I'm saying, okay, 8 goes into 24 3 times. Okay, the other way that you can come up with them is this. 8, 1, 2, 3. We multiplied by 3. 1, 2, 3, 4. You multiplied by 4. Okay, that's the other way, shouldn't have to do that, but if you do, that's another way you can do it. Okay? Now, let's look at, I think I've got some denominators that have, double-digit denominators here. There we go, 28 over 81. And 7 over 24. Okay? Now, this one obviously, you could count by 24s, count by 81, but I want to show you how to prime factor it and do it that way, okay? So if you know what it is, just stay quiet, but I want to see this. So we're looking for the LCD of 81 and 24. So we've got to prime factor both numbers. That's 3, 27, 3, 9, 3, and 3. 24 is 2, 12, 2, 6, 2, 3. Okay? So this is 2 to the third times 3. This is 3 to the fourth. So to find the LCM, LCD is also what it's called, I've got to take the prime factors that were used, 2 and 3. Now I have to take the largest power that is used. I have 2 to the third, no 2, so it's got to be 2 to the third. I have 3 to the first, 3 to the fourth, so I've got to use 3 to the fourth. Okay? Well, we already know that 3 to the fourth is what? 3 to the fourth is 24? 81. 3 to the fourth is 81 because of our prime factorization right here. 1, 2, 3, 4, we started with 81. So 3 to the fourth is 81. 2 to the third is 8. Okay? So you got to multiply those two together, 648. Y'all probably just need to stay quiet today. You're having a rough day. Okay? So, obviously, you wouldn't want to have to count by 81 until you got to 648, and then count by 24 until you get to 648. That would take you quite a while. So it's obviously you've got to know how to find the LCM using prime factorization. Okay, now, so what did we do to 24 to make it 648? Okay, how about you look at this? Okay, listen, stop guessing. Stop guessing. Okay, because 10 times 24 is 240. So when you guess a digit that's smaller than that, you're way off. Okay, so 10 times 24 is 240. Hang on. 20 times 24 is 480. Okay, so it's above 20. So 30 times 24 is going to be 720. So it's somewhere between 20 and 30. Okay? So what is it? Like I said. Could be. I don't know. That's 26, because that's going to give you a 4. 27. 27. You had to multiply by 27. Okay? Take 27 times 7, you get 169. Nope, 189. Yeah, 189. Now the other one, what'd you do to 81 to make it 648? Well, that one's easy because it's right here. You took 8. You took 8 times 81. Okay? And so when you take those, multiply it together, you get 4. Let's see, 184.
Wait, what's that number?
189. So that tells you that the 7/24 is larger. Okay, so obviously, large denominator, not all of them are going to be, that large. Most of them are not going to be that large. But there will be some that are fairly large. So, that is comparing. Okay? The other thing we're going to talk about today is ordering. Okay, but it's exactly the same, except you just got more fractions. You've got to find the LCD. So, for example, if I have 3 over 8, 9 over 32, 1 over 4, and 5 over 16, and I want to put them in least to greatest order. Okay? So we're going least to greatest. Okay? Now, as we look at the bottom numbers, so what we've got to do is we've got to find the LCD of 8, 32, 4, and 16. Well, this one's fairly easy in the sense of the largest one is 32. Okay? 8 times 4 is 32. 4 times 8 is 32. 16 times 2 is 32. So, quit yelling out numbers because you're wrong. 32 would be your LCD because that is the only number that all the other numbers can be, there's a factor they can be multiplied to get 32. So I'm going to create 4 new fractions with 32 on the bottom. Right, so the 9 just comes down. We multiplied the 8 by 4, so we do the same thing to the top, which makes that 12. Okay, the 4 was multiplied by 8, so we do the same thing to the top, and you get 8. The 16 was multiplied by 2, you do the same thing to the top, you get 10. Now, here's the important part. When you're putting them in least to greatest order, when you answer the problem, you must use the original fractions. Okay? So when I give the answer of the fractions from least to greatest, okay, I must use the original fractions 3, 8, 9, 32nds, 1/4, 5, 16ths. Okay? As we look at our top numbers on those fractions, okay, it's very clear, first of all, that this one is, the smallest one is what? 1 over 4, which was 8/32. Okay? What's the next smallest? 9 over 32. 5 over 16. And 3/8. Okay? That is your fractions expressed in least to greatest terms and in stating the original fractions. Okay? All right, now let's look at another one. No, you are too restless today. You can't control yourselves in your seat, so why would I let you get on the board? Well, that's wrong. Yes, again. You need to help her keep her mouth closed. Exactly. All right, so I got to find the LCD of 20, 15, 8, and 12. Okay? That's obviously a little harder. Okay, it doesn't just, stand out like the 32 might have. So, what I'm going to do is I'm going to show you this one by doing the prime factorization and find the LCM. That's 2, 10, 2, 5. 15 is 3, 5. 8 is 2, 4, 2, and 2. And then 12 is 2, 6, 2, 3. So I have 2 to the second times 5, 3 times 5, 2 to the third, and 2 to the second times 3. So, right here, the prime numbers that were used right there is what? What were the prime numbers used? What's the first one? 2. Okay, so 2, 3, and 5 were the only ones used, right? So that's what I'm going to put right here. Okay, this is what we talked about last night. Okay, now, 2, 3, and 5. The greatest power of 2, I have 2 to the second, 2 to the third, 2 to the second. So I got to use 2 to the third. Okay, the 3, I have 3 to the first, 3 to the first, no 3, no 3. So I've got to use 3 to the first. I have 5 to the first, 5 to the first, no 5. So I use 5 to the first. Now I take 2 to the third, which is 8, times 3 times 5. 8 times 3 is 24 times 5. 24 times 5 is 120. So the LCD is equal to 120. So I'm going to create these fractions and make 120 as the denominator. Okay? So, I multiplied 20 by 6 to get 120. So I take 6 times 13, which would be 78. I multiplied 15 by 4. Nope. No, it's less than 10. 8. Multiplied by 8. So I do the same thing to the top. That would be 88. I multiplied 8 by 15. So I got to do the same thing to the top. And that gives me 75. Multiplied 12 by 10. Do the same thing to the top. 70. So, which is the smallest one? 7 over 12. Okay, what's the next? 5 over 8. Next. 13 over 20. And the final one. 11 over 15. And that is your answers. Okay? So, Last thing. Use approximation to tell which fraction is greater. I'm glad Nicole's always so enthused to be here in the mornings. I would take it you're probably not a morning person, are you, Nicole? All right. All right. What they're basically wanting you to do is this. They're wanting you to see the two fractions, and they're wanting you to see the relationship between the two without having to do a least common multiple. Okay? This one would be fairly large if you did it. Okay? Now, how they want you to do this is this. I'm going to leave that one there. I want to show you one that's a little easier to show you on, and then we'll get back to this one. 13 over 30 and 10 over 19. Okay? I want to show you this one first because this one's a little easier to explain to you. Okay? I want you to look at 13 over 30. Okay? Well, what is half of 30? 15. Okay? So this is less than a half, correct? Because it says 13, it'd be a half, it'd have to be 15. Okay, now, over here, what is half of 20? 10. So if 10 is half of 20, 10 over 19 would have to be more than a half. Okay? So obviously then, which would be the larger fraction? 10 over 19. Okay? So you'd write 10 over 19 is the larger fraction. Now, that was easy, and a lot of them are built that way, where it's close to a half. Okay? These two are not close to a half. Okay? But they are close to 1/4. Okay? They're close to 1/4. What is 1/4 of 56? Well, to find that out, you just divide 4 into 56. 4 goes into 56 how many times? No, stop. Stop. Thank you, Joshua. Thank you for actually doing it and not just throwing out a number. 14. So this is larger. Okay, 14 is 1/4 of 56. So this fraction is larger than 1/4. Okay, what is 1/4 of 36? I know, but I'm just going one up because it's easier to find. What is 1/4 of 36? 9. Okay, so this is going to be smaller. 9 over 36 is 1/4. This is going to be smaller than 1/4. So this is larger than 1/4. This is smaller than 1/4. So the 15 over 56 would be your larger fraction. Okay? You don't even have to do the common denominator. So this one would be 15 over 56. Let's look at another one. Okay, 47 over 100 and 38 over 75. Okay, what is half of 100? 50. So this is a little less than a half. What is half of 75? No. What is half of 75? Don't just yell out answers. Actually do it. Well, it's 37 and what? 37 and a half. 37.5 is half of 75. So, if half of 75 is 37.5, this is more than a half, because it's 38. So this is more than a half. This is less than a half. So therefore, 38 over 75 is my larger fraction. Okay? So I'm gonna put one on. I want you to try to do it on your own. $223 over 500. 28 over 54. It's an easy one. Okay, approximate it. By using approximation, figure out which one is larger. And be able to explain your answer. Derek, why is it 28 over 54? All right. What is half of 500? What? 250. So actually, 223 is a lot less than 223. Half of 54 is 27. 28 is more than 27, so that's more than a half. So the 28 over 54 then is your fraction that is greater. Okay? Annie? Oh, you're reaching for the stars? Okay. All right, your homework. 4.6. Yep, 4.6. It's 4.6. No, it's 4. It is 4.5. I was looking at the next page over from the last ones I was doing. So it is 4.5. 12 through 36. Yes, and the odd. Huh? You got about 6 minutes.